Assalamu alaikum wa rahmatullah. Beta, this is the fourth lecture as far as the chemistry, surface chemistry is considered. In the previous lecture, we have discussed an important topic, that is factors affecting the adsorption of gases on the solid. At the end of the previous lecture, we have started the most important topic of surface chemistry, that is types of adsorptions. In that very lecture, I have mentioned on the basis of interaction between the adsorbate and the adsorbent, whether the interaction is weak, whether it is strong. We have two types of adsorptions. The first one, that is physical adsorption, also known as physisorption, also known as Langmuir adsorption, also known as van der Waals adsorption. And the second, that is chemical adsorption. In this very lecture, inshallah, we try to complete this very important topic, that is types of adsorptions. But the first type, that is physical adsorption. I have already mentioned what sort of adsorption it is, when the adsorbate particles are held on the adsorbent surface by weak forces. And what sort of the force are? They are of the van der Waals type. I have listed it. It is the type of adsorption in which adsorbate particles are held on adsorbent surface by weak intermolecular forces, van der Waals force, London forces. Remember this point. In this type in which the interaction is weak, van der Waals type, this type is known as physical adsorption or physisorption or van der Waals adsorption. Remember this point. Now we will discuss the characteristic features of adsorption. This is a very important topic, characteristic features. Characteristic features. Characteristic features. The first point you have to mention, that is physical change. Physical change. This is the first point you have to mention. Since it does not involve the formation of real chemical bonds, covalent bond, or you can say the ionic bond, hence it is physical in nature. And when we talk about the second type, that is chemical adsorption, that will bring a chemical change, because that involves a formation of true chemical bond, that is covalent bond, ionic bond, hence that involves a chemical change. But you have to simply hear physical adsorption involves a physical change, as it does not involve the formation of real chemical bonds between the adsorbate and adsorbent. You can mention it involves a physical change. It involves a physical change. In chemical, what you will remember, that will involve a chemical change. Here it involves a physical change. Physical change, as no real or true bonds, are being formed between adsorbate and adsorbent. Adsorbate and adsorbent. This is the first point you have to mention. The first characteristic feature, that is physical adsorption, involves a physical change. The second point you have to mention, that is it is non-specific in nature. Second point you have to mention, non-specific in nature. Non-specific in nature. What is meant by non-specific in nature? Van der Waals forces are universal. Van der Waals force, they can operate on the board, they can operate on the wall, they can operate on the rest, they can operate between the wall, between the clothes. They are universal in nature. Since van der Waals force is universal in nature, hence they can operate between any adsorbate and adsorbent. Hence we can say physical change is universal in nature. It can take place. It is non-specific in nature. It can take place between any adsorbate and adsorbent. You can mention sinus van der Waals forces. You can mention it sinus van der Waals. Van der Waals forces are universal. Sinus van der Waals forces are universal. Hence, they can operate they can operate between any adsorbate and adsorbent. Hence we can say physical adsorption, or you can simply call physisorption, is non-specific in nature. Specific in nature. The first point you have to mention that it involves a physical change. The second point you have to mention, it is non-specific in nature. It can take place between any adsorbate and adsorbent. This is the second point, second characteristic feature of physical adsorption. The third point, we have already mentioned it, it is reversible in nature. Reversible in nature. If you compare it with the chemical that involves a chemical change, it involves a physical change. That is specific in nature. Chemical adsorption takes place only when the adsorbate and adsorbent have tendency to form the chemical bonds, to undergo the chemical bond formation. That is highly specific in nature, and this one is non-specific. It is reversible in nature. I have already mentioned it while discussing the factors. If you have the gas, that is adsorbate. If you have the solid, it is adsorbent. You can say gas is adsorbate. This is adsorbent. We have mentioned it, we have discussed it. There is an equilibrium process between the two opposite processes. One is condensation. You can check the rough to see it again, to mention it again. It is evaporation. Gas gets adsorbed on the solid. You can mention it simply as gas on the solid. Gas gets adsorbed on the solid, and at that time you have also mentioned that the forward process is exothermic in nature. Heat gets released, and to what extent the heat gets released, you can mention the value. Delta H is equal to low value है 20 to 40 kilojoule per mole. You can also mention this value. This is the fourth point of physical adsorption. Enthalpy of adsorption is low. Since it does not involve any formation of any strong bond, it involves only loose weak interaction, hence less amount of energy will be released, hence enthalpy of adsorption, it will be low. This is the third important point. It is reversible in nature. Physical adsorption is reversible in nature. If the gas and the dust particles get adsorbed on the board, you can remove the dust particles by simply either by rubbing, either by decreasing pressure or by increasing temperature. You know these things. You have to simply remember physical adsorption is reversible in nature. Here you have to mention, since the condensation, it is also adsorption. जब हमने फैक्टर्स डिस्कस किए थे वहाँ पे हमने ये बोला हाई टेम्प बिकॉज condensation adsorption involves amount of release of energy, hence we do not require high temperature, we require low temperature. फिर हमने वहाँ पे एक important point बोला था low temperature. I will mention it again because the forward process, because the adsorption, because the condensation is exothermic in nature, we require low temperature, not high temperature, low temperature. But what about the pressure? High pressure, low temperature and high pressure increases the physical adsorption. Dear students, 2 points are there. The first point is physical adsorption is reversible in nature. The third, in this point you have to also mention what the temperature, it should be low. What about the pressure? By applying pressure, gas molecules will condense, they will undergo adsorption. Low temperature and high pressure increases the physical adsorption. Now I will list this point, low enthalpy of adsorption. This is the fourth point, fourth characteristic feature, low enthalpy of adsorption. Low enthalpy of adsorption. Low enthalpy of adsorption. low enthalpy of adsorption. Remember this point. Low enthalpy, it means that small amount of energy, less amount of energy is released. What is the value? 20 to 40 kilojoule per mole of energy. Low enthalpy of adsorption, since it does not involve formation of any strong you can simply remember it involves weak interaction, hence less amount of energy will be released. As a result, enthalpy of adsorption below. You can simply directly remember this point. Since it involves weak interaction, weak van der Waals interaction, since it involves weak van der Waals interaction, hence less amount of energy will be released. Less amount of energy will be released. Less amount of energy will be released. As a result, what will happen? As a result, enthalpy of adsorption. Enthalpy of adsorption will be low. And what is the value, beta? 20 to 40 kilojoule per mole. Because the interaction is weak. But the first point, physical change. Second is non-specific nature. Third is reversible in nature. The fourth is low enthalpy of adsorption. The next point we have nature of adsorbate. The fifth factor in physical adsorption, nature of adsorbate. I mean to say gas. The gas should be the extent of physical adsorption can be related with the liquefaction of the gas. The gas should be easily liquefiable. We have already discussed this factor. I will mention it just one point. The extent of physical adsorption. The extent of physical adsorption. Extent of physical adsorption is related. Can be related with liquefaction, with the degree of liquefaction, liquefaction. Now you know the four factors. You can mention it. Greater the magnitude of interaction, greater will be the critical temperature, higher will be the critical temperature, greater will be the degree of liquefaction, and greater will be the physical adsorption. You can relate those four factors which we have already related, but here simply you have to remember what the gas should be, what the adsorbate should be. It should be easily liquefiable with the degree of liquefaction. That is, the gas should be easily liquefiable. Should be easily liquefiable. This is the point. In chemical adsorption, there is no such correlation that these two are, the physical and chemical, they are entirely different. In physical adsorption, it involves physical change, chemical adsorption, chemical change. This one is non-specific, that is highly specific. It is reversible, that is reversible. Low enthalpy of adsorption, that involves a true chemical bond. High enthalpy of adsorption. This one, nature of adsorption, the gas should be easily liquefiable, but in case of chemical adsorption, there is no such correlation. In chemical adsorption, the gas, the adsorbate, must have tendency to form the bond with the adsorbent. There is no such correlation whether the gas is easily liquefiable or not in chemical adsorption. This is not necessary. Liquefaction point is not necessary among this point. Nature of adsorbate. The next point we have to remember in case of physical adsorption, that is multimolecular layers are being formed. Multimolecular layer formation. Multimolecular layer formation. You have to remember, under high pressure, when the pressure is high, multimolecular layers can be formed on the adsorbent surface. For example, this is the board, this is the dust layer. One. After some time, there will be more and more layers on the basic layer, because the van der Waals force are universal. This happens. This is the way. It means that in case of physical adsorption, under high pressure, multimolecular layers can be formed. You can mention under high pressure, number of layers, multi layers are being formed on adsorbent surface. Adsorbent surface. It means that you have to simply remember here, more and more layers are being formed. This is the base layer. Van der Waals force is universal. They can operate here. Multimolecular layers are being formed on the adsorbent surface. Remember this point. Then the next factor you have to remember, no or low, because in physical adsorption we need low temperature, because it is exothermic. The forward setup is exothermic, energy is released. We don't need any kind of energy. If you need, that will be very low. We don't require any activation energy, and because it does not involve formation of chemical bonds. Hence we do not require activation energy, high activation energy. You have to remember the seventh point. No activation or low activation. If we require, that will be very small, negligible. No activation or low activation energy. You can remember, since it does not involve formation of real chemical bonds. I mean, say here covalent or ionic real chemical bonds. Hence, no activation energy is needed. No activation energy is needed. You can also mention, it means that these 7 points, they are different. They are different in case of chemical adsorption. Remember this point. The 8th factor you can mention, surface area of adsorbent. The 8th factor, that is surface area. Greater the surface area, it is clear, we have already discussed it. Greater the surface area, greater will be adsorption. You have to mention these 9 characteristic features in case of physical adsorption. Remember, fine. Now we have the second type, that is chemical adsorption, chemisorption, Langmuir adsorption, or activated adsorption. I will list just the first name, that is chemical adsorption. chemical adsorption. You can also mention chemisorption. You can also mention Langermeyer adsorption, or you can mention activation adsorption, because we require energy here for activation, for bond formation. What sort of chemical adsorption? What sort of adsorption? It is the type of adsorption in which adsorbate particles are held on the adsorbent surface by strong chemical bonds, that is covalent or ionic bonds. From this point you can mention it is the type of adsorption. You can mention it is the type of adsorption in which adsorbate is held on the adsorbent surface, by strong chemical bonds. Strong chemical bonds, they can be either covalent or you can say ionic. Remember this point. Adsorption in which it is the type of adsorption in which the adsorbate is held on the adsorbent surface by strong chemical bonds. Remember this point. When the chemical bond is being formed between the adsorbate and the adsorbent, it means that because of, when the chemical bonds are being formed, what happens is compounds are being formed. Hence you can say this type of adsorption results into the formation of surface compounds, because compounds will be formed on the surface. For example, if you have the nickel surface and if you have the hydrogen, if there is chemical adsorption, if there is chemical bond formation between the nickel and hydrogen, you do not have the hydrogen on the surface, instead you have the nickel hydride on the surface. This is the point you have to remember while distinguishing physical and chemical. Physical adsorption does not involve the formation of surface compounds, but chemical adsorption involves the formation of surface compounds. If you try to remove the hydrogen gas from the nickel, you can't do there, because you can remove the nickel hydride. Hence we are saying that this adsorption is irreversible. You can't remove the hydrogen gas, just like in physical. If you try to remove the adsorbate, you can remove the compound but not the adsorbate. Hence you have to remember here it is irreversible in nature, and physical is reversible. This one is irreversible. You can mention it involves formation of surface compounds. This is the point you have to remember while distinguishing physical and chemical. Physical does not involve the formation of surface compounds, but this one involves the formation of surface compounds. Now we will try to discuss the characteristic features of chemical adsorption. Characteristic features. Opposite to physical. I will suggest the name. Now you know the things. That when is physical change, the first point here, it involves a chemical change. You can mention it. Physical involves physical change, it involves chemical change, because it results into the formation of real chemical bonds. I have already mentioned it, real chemical bonds, that is covalent or ionic. Hence it involves chemical change. Physical is non-specific in nature. It is specific because adsorbate and adsorbent must have tendency to undergo bond formation. For example, if you have the nickel surface and you have the, for example, helium, there will be no adsorption, because nickel and helium, they do not undergo the bond formation. You can say the second point, it is highly specific in nature. The second feature is highly specific in nature. You can mention it takes place. Chemical, I am talking about the chemical adsorption. It takes place only when adsorbate and adsorbent have tendency to undergo chemical bond formation. You have to mention it. But physical adsorption is non-specific. Here you have to mention it. It is highly specific in nature. Now the third characteristic feature you have to remember here, in physical you have mentioned that is reversible. Here you have to mention it is irreversible in nature. I have already mentioned it. The third characteristic feature, it is irreversible in nature. Irreversible in nature. You can mention here, if you try to remove the adsorbate, instead of adsorbate, surface compound can be removed. It means that it is reversible in nature. You can mention this point. If you try to remove the adsorbate, I mean say gas, instead of that, what we can remove? We can remove the surface compound, because surface compound is being formed. It is irreversible in nature. The fourth point is unimolecular synescete involves formation of strong bonds. Synescete involves chemical strong covalent bond, ionic bond, hence tremendous amount of energy will be released. Then what will be the this enthalpy of adsorption? High enthalpy of adsorption. High enthalpy of adsorption. In case of physical, we have low enthalpy of adsorption, but here we have beta high enthalpy of adsorption. You can mention it. Synescete involves formation of true chemical bonds, true strong chemical bonds, hence tremendous amount of energy will be released. You can mention synescete involves, we can mention it, synescete involves true chemical bonds, true strong chemical bonds, true strong chemical bonds. Through strong chemical bonds, hence therefore large amount of energy will be released. A large amount of energy will be released. Large amount of energy will be released. That is enthalpy of adsorption. Enthalpy of adsorption is high. Enthalpy of adsorption is high. And what is the value? You should remember the value here. Enthalpy of adsorption is high. The value is 200. Instead of 20, it is 200. Instead of 40, it is 400 kilojoule per mole. This is the fourth point you have to mention, the high enthalpy of adsorption. In case of physical, we don't require any kind of activation energy, but here what you have to remember, since it involves formation of chemical bonds, hence high activation energy is needed. You can simply mean high activation energy. High activation energy. Why this type of adsorption is known as activation adsorption? Because we require high activation energy. Why we require high activation energy? You can remember here, you can mention here, since this type involves formation of strong chemical bonds, hence tremendous amount of energy will be needed as activation. आपने पढ़ा होगा chemical kinetics में, whenever there is reaction, we have to first supply energy. We have to first supply energy, hence this type generally occurs at high temperature. Physical adsorption occurs at low temperature because we need high temperature here, high energy here, high activation energy. Hence, it generally occurs at high temperature. You have to mention high activation energy. Remember this point. Hence, since we need high activation energy, hence it is also known as activation or activated adsorption. Remember this point. High activation energy. The sixth point we have unimolecular layer formation. In case of physical, multimolecular layer formation takes place. Here it is unimolecular layer formation. Unimolecular layer formation. For example, we have the nickel, we have the hydrogen. Bond is being formed between the nickel and hydrogen. Bond is being formed between the nickel and hydrogen. It means that this is chemisorption, this is chemical adsorption. Now, no new layer will be formed on the base layer. In case of physical, van der Waals interaction is there, weak interaction is there. If you have this surface, this is dust particle first layer, this is second because van der Waals force is inversal. But here it involves the formation of chemical bonds between the adsorbent and adsorbate. What happens? Only one layer will be formed on the adsorbent surface. You can mention unimolecular layer formation. In case of physical, multimolecular layer formation is formed. In this case, unimolecular layer is formed. Remember this point. The seventh point you can mention surface area. Surface area. यहाँ पे वही याद रखना है. This is common point in both these cases. That is, greater the surface area, greater will be the chemisorption. Yeah, greater the surface area, greater will be the physisorption. It is common point. Now the question which comes in the exam, which you have to remember for the examination purpose, that is distinguish between physical and chemical adsorption. You have to draw a column and mention simple points. This one is physical adsorption, this one is chemical adsorption. Physical adsorption and chemical, you have to draw. It will take just 2 or 3 minutes to mention, to write this table. You can mention the first point. It involves a physical change. It involves a physical change. What you can mention here, it involves a chemical change. Second point, it is, we have discussed these things, it is non-specific in nature. It is non-specific in nature. Here it is highly specific in nature. It is highly specific in nature. You can mention it. The third point, it is reversible in nature. We have discussed this, why it is reversible, because interaction is weak, reversible in nature. Third point, it is irreversible in nature. It is irreversible in nature. The fourth point here you have to mention, low activation enthalpy, low enthalpy of adsorption. Low enthalpy of adsorption. Low enthalpy of adsorption value कितना है बेटा? 20 to 40 किलोजूल पर मोल. आपको याद रखना है. यहाँ पे आपको क्या याद रखना है? High enthalpy of adsorption. High enthalpy of adsorption. High enthalpy of adsorption. But you should know why enthalpy of adsorption is low, high and low, because interaction is weak, less amount of energy released, hence enthalpy will be low. की वैल्यू कितना है यहाँ पे? 200 to 400 kilojoule per mole. This is the value you have to mention. The next point, fifth point, no activation energy is needed. No activation energy is needed. You should know why no activation energy is needed, because it does not involve any formation of chemical bond. No activation energy is needed. no activation energy is needed. What you can mention here, fifth point is high activation energy is needed. High activation energy is needed. High activation energy is needed. You can mention it. High activation energy is needed. Energy is needed. You can mention more and more points. Unimolecular, यहाँ पे multimolecular. 6th point, multimolecular layer is formed. We have discussed because van der Waals forces are inverse. Multimolecular layer is formed. Multimolecular layer is formed. 6th point, unimolecular layer is formed. Molecular layer is formed. Why unimolecular layer is formed? Because chemical bond is formed between the adsorbate and adsorbent. Valencies are being satisfied. Now no new valency, no new layer will be formed. No surface compound is formed. It does not involve the formation of surface compound. I mean to say no surface compound is formed. No surface compound is formed. Surface compound is formed. What you may remember here, surface compound formation takes place. Surface compound formation. Surface compound formation takes place. Surface compound formation takes place. Surface compound formation takes place. You have to remember. The gas should be easily liquefiable. यहाँ पे liquefaction correlation है. The gas should be easily liquefiable. Should be easily liquefiable. यहाँ पे आपको याद रखना, there is no such correlation. There is no such correlation. There is no such correlation. It is specific. This one is non-specific. That is specific. Physical change, chemical change, multimolecular, unimolecular. Remember this point. You have to mention. It is no surface compound is formed. Surface compound. There is relation between the liquefaction and the adsorption. There is no such correlation. This was about the important topic, that is types of adsorption, physical and chemical adsorptions. And inshallah in the next lecture we will discuss the Friendlich adsorption isotherm. Till then, fi amanillah.